Hello again, it's Milosoft. Today we're going to take a look at Mission Impossible and how to remove the protection. If we take a look at the directory, there's a one block runme file, a loader, title, words. I'm going to guess that words is the speech, imp, which is the main game, and hi, which is either a greeting or the high scores. First thing we're going to do is we're going to load runme. And then we're going to go into the monitor immediately and take a look at around 0200, roughly 0200. Now I've been doing, I think this is my 14th video on copy protection, and for the sake of those who haven't watched the 13 other videos, I'll say what I always say. To get into the monitor on the CCS emulator, it's Alt-M. If you're using Vice, it's Alt-H. Unless you're using the old Vice, in which case it's Alt-M. And if you take a look at around 0200, you can usually find the code for the auto boot, the file that runs automatically when you load it, 8,1. And we have at 02D9 3 lines of code. We set A to 3, we set X to FD, and Y to 2. Now remember the saying, Y is high. So the address is 2FD as we read it, high byte, low byte. And this is setting a file name. FFBD sets a disk file name at 2FD. So it's loading LO star. Because it's 3 characters, we can see LO star. And then it loads A with 1, transfers it to Y, and sets X to BA. BA is the device number. So if you're running a drive on device 9, BA would be 9. And then it calls an FFD5, which does the actual disk load. Then it loads the accumulator with 36 and stores it in location 1 and jumps to B1000. So what that's doing is B1000. As you can see here, we're jumping to B1000. B1000 is normally not an area of memory that you can put stuff in because it's occupied by BASIC. Unless you switch out basic ROM by putting 36 into 1. So if we take a look at A1000, it no longer says CBM basic as it used to. In fact, it's totally empty. And we can see at B1000 we have code. So we've set our file name to LO star. We've conducted the load. We set 36 to 1 and we jump to B1000. With that in mind, let's just do a reset and do the same thing. Load LO star, 8,1. Done. And we're going to check 2D and 2E, which is the end address. The end address of the file that we just loaded. So it's safe to conclude that our file is from B1000 to B1A2. And if you look at A1000, you see it says CBM basic. And if you look at B1000, there's no loader code here. This has nothing to do with Impossible Mission. But remember, location 1 was set to a 36. So if we type bank 0, what it does is it turns off the A1000 and B1000 basic. And now when we look at A1000, it doesn't say CBM basic anymore, and B1000 looks more like it should. Reiterate. Loader loads LO star 2 sets 01 to 36. It'd be nice to make one video without a typo, you know? So A1000 and B1000 are open. 3 jumps to B1000. So this file loads this file, which executes B1000. And now we get into what the loader does. You'll see in a lot of my videos that I go to disassemble an address, and then I go down here and I do it again. The reason I do it is so that you get it all in one little paragraph instead of one up here and the rest down here. And this is the routine. 12, 13, 14. So it's loading this value here, exclusive ORing it with this one and storing it here. That doesn't really make sense because it doesn't start till here. But you know what? For all intents and purposes, I really don't care. It's doing some encryption. It's doing some exclusive ORing. The only real machine code is here. These 1, 2, 3, 4, 5, 6, 7 lines of code. Does a little bit of encryption. And what it does is it decrypts this code here. So while this is executing, it goes here, 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 and when it's done, it falls through to here. But because this is decrypted, it's no longer garbage, it's true machine code. So what I'm going to do is I'm going to, let's see, make a little routine, load 36, store in 1, and jump B1000. I'm going to immediately go in and take a look at B1000, and it's now decrypted. What used to be garbage is now drive code. So FFE7, which closes devices, FFBD, it loads 15 because F is 15. And then X is BA, which is your drive 8. Transfers 15 to Y. And that sets the logical file. And then it opens a file name that is 1 character long at FB. So it's loading A with 23 hex and storing it at FB and setting FB as the file name. If I put a 23 there, that's a number. Okay, so I have a better idea of what it's doing. I'll write it out for you. This puts the number sign at location FB. This sets a file name that's 1 character in length, and the file name is located at FB because there's no high byte, so it's actually 00FB is our file name pointer, which is basically opening a buffer. FFCO. And then this sets 0 page So this sets FB to 0, and FC is 80. So that means that bracket FB equals 8,000. How did I get 8,000? Because we're putting 0 in FB and 80 in FC. So it looks like this. 0080. FB 0, FC 80, and because we're using the curly brackets, it means go to FB and get the low and high at byte. So it's really saying 8,000. This is just another fancy way of saying store at 8,000, Y. It's probably done just to try and confuse people. So what this routine is doing sets the 0 page to 8,000, and this loads 50B2, Y, where Y is 66, stores it at 8,000, Y, decrements Y until Y wraps around past 0 and goes back to 255, and then jumps to FB. You see this jump is in brackets? So because it's in brackets, it's the same as saying jump 8,000, because 0 is low byte. So low byte, and 80 is high byte. It's just a fancy way of putting code at 8,000 and then executing it. Okay, what are we going to do here? I think the best way to proceed is to make a breakpoint. So we go breakpoint add 8,000 X. So when there's any attempt made to execute anything at 8,000, it's going to stop and it's going to alert us. If you're using the Vice emulator, you can type break oh goodness, I know store 8,000 works, but I'm not sure what it is for execute. It might just be break exec. I don't use Vice very often, and I make no apologies for that. I don't really care for it. Okay, here we go. And it's kicked into the monitor. I exited briefly and it kicked in saying, hey, it has now tried to execute 8,000. So it's copied code from B1000 down to 8,000. This is what it's done so far. So the first thing it does is calls 803F with a JSR. A JSR is like a go sub, meaning that it intends to come back from it. It'll go off and do its thing until it sees an RTS. When it sees an RTS, it says, oh, it's time to come back to here. Just like a go sub works. So what this is doing is it's setting default device to 15, and it's loading 8057 using Y as the offset. So this is the U1:30163. U1 is a command to read in a sector. So it's using buffer 3, track 16, sector 3. And it's printing it to FFD2, which is now being the drive channel. So it's saying read track 16 sector 3 for me, please. And then it increments Y, so it goes to the next character, and the next, and the next, and the next, until it hits a 0, which is at the very end of the command. And when it sees a 0, it says, oh, okay, branch equal down to here. And because that's a jump, normally that would be a JSR, but because it's a jump, it will come back to here. And what this does, we get into some more sneaky stuff. So track 16 sector 3 is a whole slew of memory addresses. It's not game data, it's just a whole slew of addresses. It's some real sneaky stuff. And it grabs a byte and it exclusive ORs it and it stores it at B1000. It exclusive ORs FB, stores FB. We've got, and then it closes the channel. So reads track 16, grabs a series of bytes. This is some really tricky stuff. And at the very end, what it does, it closes the devices. It puts a 4C into A, the accumulator. It does a bit 8000F. It stores that 4C in 8000F. So that 4C goes right here, which changes it to a jump B1000. Pretty tricky, eh? Jump B1000. What we can do at this point, just see if it's all decrypted. No, it hasn't decrypted yet. At this point, I'm going to do a fresh reload with a breakpoint at 8000 for execute. And I'm going to go down here, and right here at 8034, where it changes 8000F to a 4C, makes this to a jump. I'm just going to make this go into an infinite loop. 8034 jump 8034. Okay, now as you can see, it's in the infinite loop at 8034. But at the same time, this whole exclusive OR process is done. So if we look at B1000, we should have all of the impossible mission decrypted. It's doing another disk load at B11F, which loads title and words. So I think we're good to go. We're at the point where we have successfully decrypted the loader. Now we just have to figure out how much of the memory to save. And this is a skill that you acquire over time. So far, this is empty memory. You see a little bit of garbage here, but for the most part, there's nothing here. Empty RAM. This is the code that we were able to decrypt. That's okay. So this is going to be a pretty simple process. We're going to save loader from B1000 to, let me see, we'll go to about B1A4. Okay, and that should hopefully do it. We'll do a hard reset. We have to bank out ROM. Okay, let's see if it works. We'll create a little loader. Put it in 1 so that we have B1000 enabled for us to execute. And that should work. There we go. Now, that was half of the battle. The other battle is going to be, let me just switch over here. The crack works. So we take Impossible Mission. We're going to create a new disk, a D64. We're going to copy all of these files over, and we're going to save it as new disk. Okay, now let's see if we can import. I'm going to go to my C64 directory, and somewhere in here I should have loader. There we go. Unable to open loader. I think I know why. It doesn't have a PRG extension. It doesn't think it's a program file. There we go, loader. Okay. So here's our boot file, which loads LO star, sets 36 in 1, jumps B1000. Here's our cracked loader file that doesn't call the protection. Is it going to work, do you think? Do a hard reset. The difference between a soft reset and a hard reset is a hard reset is like turning the machine off and back on. Okay, here we go. Cross fingers. We have successfully removed the protection from Impossible Mission. Perfect. I wonder if we can go a step further. Let's see how many lives we get. So there's 1 life, 2, 3, 4. I don't know if it's necessarily a game where you have a certain number of lives or not. I guess in a way you do. Well, I'm not going to do a trainer on this one. So, you've successfully cracked the game. I'm going to really quickly go over the process that we used. So, we loaded RunMe. We disassembled 0200 down to about 0300 to see how the loader works. 0200 is where you'll find a lot of the, pretty much all of the auto loading files. we found a 2-character file name, a 3-character file name at 2FD, which was LO star. And then we saw it jumps to B1000, which means we load loader, and we cannot go to B1000 just yet because this is still Commodore Basic, right? We have to bank out the ROM, and then we can see the code. Next, we had to allow it to decrypt. So to do that, I made a custom program, but you could very well just do this. And then set a breakpoint. Well, you wouldn't know it jumps to 8000 just yet, so just let it go. Disassemble B1000. Now you see the code and where it jumps to 8000. So now you can put the breakpoint. And then here, where it changes 8000F to a 4C, it does that so it becomes just a jump B1000. So what we did was we just saved B1000. It hasn't run yet, so it's not there. But when it is, we just dumped it to disk as a file called loader. We imported it into dir master, this little file here, and it's done. No more protection. This is Milosoft saying thank you for watching. If you like my videos, don't forget to like, comment, or share it with your friends. Bye.